right? You're working
Yeah.
hard all day in the operating room.
If you pan the camera back though, that's it. It's just the top and the shirt, right? Pajama pants on the bottom,
So,
scrub bottom.
No pants. No
well,
pants.
that's the pandemic outfit.
Yeah.
All right, guys, we are
Pandemic's-
live on multiple streams now, so we're good.
Excellent. Are we at 4? We're at 4 too, so we'll get started. So welcome everyone to another edition of Tumor Talk. You guys may remember this as the collaborative effort between Lenox Hill Neurosurgery and the Journal of Neuro-Oncology, where we highlight recent publications and talk about, the ideas behind them as well as the relevance to the future of neuro-oncology. And so we're pleased to have back actually Yoshua Eskenazi discussing this paper about basically prognosticators for tumor treating fields. And the results are fabulous. So I'm really glad you're back. Why don't you introduce yourself and introduce who's with you today, and we'll get started.
Yeah, hi everyone. Thank you again, Randy, Nitesh, Dr. Shian, and everyone. And we're very excited to be here as a team. And I'm here with Dr. Leomar Ballester, who's a molecular neuropathologist. We've been working together on many projects, and particularly in this one as well. And then Antonio Dono, who's on the majority of the work here, he just applied to the neurosurgery match, and he's from El Salvador, and he matched in neurosurgery this year. So he will be starting a residency next month. So he will be
Congrats.
attending, and we're excited to be here. Why don't you go ahead, Antonio, and start?
Good afternoon, Nitesh. Good afternoon, Dr. Amico, and everybody that is listening to us. My name is Antonio Dono, and this is the work that we have been doing with my mentors, Dr. Joshua Eskenazi and Dr. Leomar Ballester. It is called PTEN Mutations Predict the Benefit from Tumor Treating Fields Therapy in Patients with Recurrent Glioblastoma, a work that we have been done at UT Health, McGovern Medical School, and Memorial Hermann Texas Medical Center. Just to start, I would like to introduce some concepts. And glioblastoma, as we all know, is a disease with a dire prognosis. With maximal surgical resection and chemotherapy, it invariably recurs, and no treatment for recurrent glioblastoma has been demonstrated to improve overall survival in randomized clinical trials. Tumor treating fields has been shown, and is very important to talk because it's our topic today, to improve progression-free survival and overall survival in newly diagnosed glioblastoma. In the recurrent setting, Tumor treating fields was compared against the best physician chemotherapy choice, and it demonstrated that it was not inferior for PFS and overall survival in the recurrent setting. However, nobody knows which patients will improve better or will benefit most from tumor treating fields therapy, and if there is any biomarkers that will provide for benefit of tumor treating fields. Therefore, before we start with our talk, we have to talk a little bit about the mechanism of action of tumor treating fields, that even though it is incompletely characterized, the studies have shown that tumor treating fields acts in the dividing cells and not in the cells that are quiescent. So tumor treating fields alternate electricity will cause a dipole alignment, which will cause a microtubule disruption. This microtubule disruption in the metaphase, especially in the anaphase, will cause a mitotic delay arrest. This mitotic delay arrest ideally will cause a death of the cells during the mitosis, in which when they cannot divide and they will go apoptosis at the end. However, if the cells are able to divide and they will go to the telophase, there are two outcomes that can happen. If the tumor cell is able to elude the tumor treating field therapy, they will go a normal division, and if this one go to a normal division, they will go again to a tumor treating field in the next dividing cycle. But most of the times what it happens is that the division is abnormal, because there is a abnormal chromosome alignment and distribution between the cells. This will cause in most of the case two scenarios. One is that there is going to be a death by apoptosis in the interface, and the other one is that there can be an arrest in the interface. There is always some cells that will sleep from the mechanism of action of tumor treating fields, and if they sleep during the mitotic arrest, because they are not able to divide, they will have aneuploidy, and this aneuploidy will go further division and again to a tumor treating fields mechanism of action. This is the proposed mechanism of action, as I said, but it's still not completely understood. So for a study, what were the goals? The goals for a study were to evaluate the survival effects of tumor treating field in a cohort of patients with IDH wild-type recurrent glioblastoma. Why this? Because both clinical trials that I mentioned initially were performed before the current molecular characterization of glioblastoma. And as well to investigate the possible clinical characteristics or genomic alterations that might predict the responsiveness to tumor treating fields, to understand which patients will benefit the most from this therapy. So what did we do? We look at patient tumor samples from 2010 to 2019, because in 2010, Tumor Treating Fields was started in our institution. This patient had to be included in this study. They have to have certain characteristics like pathology-proven IDH altered glioblastoma, tumor treating fields at the first recurrence, tumor treating field treatment at least for 4 weeks, because it has been shown in previous studies that if you give it less than 4 weeks, the therapeutic effect is almost null. And next generation sequencing available for these patients. The next generation sequencing was performed for 205 genes and 26 genes rearrangements. And we evaluate the post-progression survival and overall survival. Why post-progression survival? And we focus on this one because other studies evaluating therapeutics at the recurrent setting in glioblastoma and other cancers have shown that overall survival is usually biased by a lead time bias. So post-progression survival will give us a more accurate outcome. So to start, we evaluated 530 infiltrating gliomas in our cohort, and we excluded all patients that were not treated with tumor treating fields. We had 156 patients that were treated with tumor treating fields, but some more had to be excluded because 59 didn't have any genomic characterization, 13 were not glioblastoma at the first recurrence, they were other type lower grade glioma, and 6 were GBM-IDH mutant, which now we know, according to a CIMPACT now 5, they should be considered a different disease and even not called maybe glioblastoma, and instead astrocytoma grade 4 IDH mutant. We ended with 78 patients, but we wanted to have a more homogeneous cohort. Therefore, we excluded the patients that were treated with tumor treating fields in an upfront therapy, because these patients cannot be evaluated with the ones that were only treated in the recurrent setting. We also excluded the patients that were treated with tumor treating fields after the second progression, because this will have tumor treating fields for a shorter period, and on the second progression, the tumor might be different. And one patient that did not have treatment for more than 4 weeks. We ended up with 29 patients in a very homogeneous cohort, and we compared these 29 patients against 120 glioblastoma patients with documented recurrence and genomic characterization that we took from the 530 infiltrating glioma database at our institution. So first, we're going to see the characteristics of these 29 recurrent glioblastoma IDH wild-type patients treated with tumor treating fields. We can see that the median age was 58 years of age, and that most patients were treated with salvage chemotherapy as temozolomide, bevacizumab, besides tumor treating fields. We divided the patient by the PTEN status in PTEN wild and PTEN mutant, because we will observe in our study PTEN mutation was a predictor of survival for these patients. And we can observe that there was no significant difference in between these two groups, except for the salvage bevacizumab therapy in the PTEN wild type patients, in which the PTEN wild type patients had more treatment with salvage bevacizumab than the PTEN mutant patients. So
is there a clinical reason for that, or is it just how it turned out?
It was how it turned out. We didn't select anything in that way. It was like that. So here is practically the core of our results, is that the tumor treating, we're going to see these 4 figures. In A, we're going to just to compare the 29 patients that were treated with tumor treating fields against the 120 patients that were not treated with tumor treating fields. And we observed that there was not a significant difference in post-progression survival. Just to remind the audience that post-progression survival is the survival from the first recurrence. However, in B, we can observe that when we took those 29 patients that were treated with tumor treating fields and we divide them by the PTEN status, the patients that were PTEN mutant have a remarkable improved survival of 22.2 months after the first progression, or the median post-progression survival, compared to the PTEN wild type that was 11.6, which was statistically significant. To further confirm our results, we took from the complete cohort of 149 patients and we divide them by PTEN mutant or PTEN wild type. And these PTEN mutant recurrent GBMs, that there were 7 in total, we divide them further by the tumor treating field therapy. So the PTEN mutant patients that were treated with tumor treating field therapy had an improved survival compared to the PTEN mutant patients that did not have tumor treating field therapy. as we can see, is statistically significant and is more than the double the post-progression survival. Why do we do this? To observe that it's not the PTEN mutation that is causing the survival benefit, but it's the therapy when the PTEN mutation is present. Because as we can observe in D, when there was PTEN wild-type patients, the treatment with Tumor Treating fields did not do any difference because the survival was, the median was the same and there was no statistical significance. To confirm our results that they were not confounded but by the most common variables, age, KPS, and the salvage therapies at recurrence, we perform a multivariable Cox regression analysis, and we observed in the 29 patients that PTEN mutation status was a marker for survival benefit in those 29 patients that received Tumor Treating field therapy that was independent from age and KPS. KPS, as well-known prognostic factor for survival and post-progression survival, was as well significant in this multivariable analysis. Then in the 70 patients that were PTEN mutant, the recurrent GBM, we observed that the salvage treatment with Tumor Treating fields at the first recurrence was statistically significant after the adjustment of age, KPS, extent of resection, and the most common salvage therapies in our cohort, temozolomide and bevacizumab, in which it has a ratio of 0.29, was for salvage Tumor Treating fields. We also look at the overall survival. Why? Because most people always think about overall survival, even though it's not the ideal scenario because this is a therapeutic in the recurrence. But we analyzed this one, and in the overall survival, meaning the survival from diagnosis, there was no significant difference between the Tumor Treating field therapy treated patients and the non-Tumor Treating field therapy patients, the 29 against 120 patients, the complete cohort. In B, that we divided the cohort again in PTEN mutant and PTEN wild-type patients. Those 29 patients, the ones that were PTEN mutant, have a remarkable improvement in overall survival, having a survival from initial diagnosis of 30.8 months compared to 16.6 in the PTEN wild-type patients, almost doubling the survival of these patients. In C and D, again, we have the whole cohort, the 149 patients divided by PTEN status, and the 70 patients that were PTEN mutant, even though it didn't reach statistical significance. There is a difference in survival, a median overall survival of 30.8 compared to 16.8 of the PTEN mutant patients if they received Tumor Treating field therapy. If the patients were PTEN wild and they received Tumor Treating field therapy, this one did not change the prognosis of the patient and have a non-significant difference in overall survival. And as you can see, even the ones that received Tumor Treating field therapy do a little bit worse. So where does this fit? Where does PTEN fit in the Tumor Treating field? And this is a review paper by Hu et al. Actually, PTEN is a well-known cellular, a well-known marker, well-known player in the division of the cells. And as we can see in the center of the figure, PTEN maintains the centrosome and the chromosome alignment and division. And when PTEN is absent, as we can see in the figures at the side, there is a phosphorylation of AKT, EGFI, and PLK1 that cause a supernumerary centrosomes, spindle cell shortening and pole fragmentation, chromosome non-disjunction, cytokine failure, and polyploidy, will cause a defective spindle geometry overall, and this will cause that the cell will not divide properly. If we interpose what was the mechanism of action of Tumor Treating fields, we can see that it's very similar where they are acting. So it is feasible that patients that have PTEN mutation that have already the mitotic machinery, they have a defect in the mitotic machinery, they will be more prone for the cells to die with the Tumor Treating field therapy. Therefore, the conclusions of our study was that PTEN mutant glioblastomas have a significantly improved survival benefit compared with PTEN wild-type patients when treated with Tumor Treating field therapy at recurrence. This is very important clinically because right now there is no therapy that has been demonstrated to improve survival at the recurrence setting, but maybe this is because we have not been selecting the patients properly. So patients that have the PTEN mutation, they very likely will benefit more from Tumor Treating field therapy, but PTEN wild-type glioblastoma might not benefit at all from this therapy. This also opens new venues of treatment in which there might be a possibility in the role of Tumor Treating field therapy with the addition of PTEN or of the pathway inhibitors to improve the survival of all GBM patients, and understanding the molecular mechanism that predict differences in response of tumor treating field has the potential to further clarify the mechanism of action of this therapy. Where the future directions of our project is both in vitro and animal models have to be performed of both PTEN mutant and PTEN wild-type cell lines and tumor models to further elucidate this mechanism of action. And a prospective study evaluating the effects of tumor treating field on both newly diagnosed glioblastoma and recurrent glioblastoma are needed to validate our results. Some effort that both my PIs are trying to perform in our institution, and we hope that we have it in the future. Thank you very much, and thank you, Randy, for inviting us, and thank you for JNO for publishing our work, and thanks to both my mentors, Dr. Leomar Ballester and Dr. Joshua Skenazy. And as you can see, here's a picture of one of our lab meetings where we have been doing online and WebEx because the pandemic of COVID-19, but we hope that soon we can return to our work more normally. Thank you, and I will get any questions right now.
Thanks so much, Antonio. That was great. Look, I think, and one of the reasons I was so excited to talk about this paper is that the results are significant, right? You're talking about doubling progression-free time in a recurrence setting. And these are long periods of time. Has this kind of changed how you're giving tumor treating fields, or are you still giving it to everyone just because why not?
Yeah, I mean, I guess we can, yeah, thank you. The results are surprising. And obviously, I think the mechanism of action of PTEN and everything seems to go together. Obviously, this is a retrospective study, and it's a small number of patients. So we initially presented this as an abstract 2 years ago at SNO, and there was a lot of interest from Novocure. And we've been in very close collaboration with them. And I guess Leo can speak more about it, but the goal is to further validate more of the samples. Leo, do you want to talk a little bit about the grant and the collaboration with Novocure that's currently going? You're muted.
Sure. Yes. I think that the short answer to the initial question is we're still not changing how TTFs are given, or at least that the neuro-oncologists are not. I think it's a small study still, even though the results are significant. You will want to confirm it before making that decision. But it does point towards like PTEN being a significant determinant of whether or not the patients will respond. So we're in the process of doing additional experiments to try and confirm these results by increasing the number of patients that have already received treatment, but we don't have sequencing information for. So we're going back and sequencing many of these patients so that we can increase the sample size. And then we're also in the process of setting up a prospective study where we follow patients and look at PTEN status early on and follow them and see if this really pans out to be in a prospective study to determine whether or not the patients will respond to TTF.
Yeah, well, I think, there's a few things that I think are super important about this. So number one, what do you think the prevalence of PTEN in the GBM community is at large?
I think PTEN is about, most studies show PTEN about 40% or like somewhere around that, which is quite high.
It's a high percentage without a doubt. And in general, at least in my teaching, PTEN is thought to confer a negative prognosis, right? And so here you have something that's pretty frequent and conveys a negative or confers a negative prognosis. And then, the tumor treating fields in this situation is actually extending that in a pretty remarkable way. Again, it's a small study, but it's the groundwork for something that potentially has a very large impact. So I think it's really fantastic.
Yeah. No, it's very interesting. We started the study with no preconceived idea of what genes were going to be like relevant, and then PTEN turned out to like stand out from the rest. And it's like why PTEN? Well, I was really surprised as to why PTEN turned out to be. And then you start looking into what is the proposed mechanism of action of TTF and the role of PTEN into setting up the mitotic spindle. And it kind of makes sense that PTEN mutations may sensitize cells to the effects of TTFs. So
it's a synergistic kind of mechanism.
Exactly.
Yeah. Nitesh, any questions?
I think this is really interesting. I mean, I think you might have hit the nail on the head there, Randy, with just the fact that the overall survival and progression-free survival curves. I mean, you look at the 50% line; it's a major increase using this combination. So I think this is a pretty awesome study. I'm glad we got to get these guys, for a third or fourth time now, last 6 months on Tumor Talk with us. It's pretty awesome,
They're prolific.
I know, prolific, contributing to the journal big time all year long.
Giving
awesome
Miami a run for its money.
I know. I'm gonna tell Rick when I get down there next month.
Yeah, Nitesh is going down.
Sleep.
Where are you going, Nitesh? I guess.
I'm going to Rick Homitar's Fellowship in Miami in starting July. So
I see.
Yeah. I do have another question. The only other data point that I thought was really interesting was the prevalence of bevacizumab treatment, right, in the groups. And so I wonder, could treatment with bevacizumab also have a synergistic effect with the tumor treating fields? Have you guys looked at wild type or mutant and or just bevacizumab, yes or no?
Yeah, we look at it in relationship to tumor treating fields, and we haven't really found anything. The question is, as you know, most studies on bevacizumab haven't really been successful. But the question is, are there any molecular groups that benefit from bevacizumab? And that's something we're also working at. A few years back, we published actually on JNO about EGFR patients, and there may be a subset of patients that respond to particular therapies. And I think that's the goal in the next 10 years, to do precision guided medicine, just like they do in lung cancer or in melanoma, where they're treating patients according to the tumor type rather than just treating everyone with the same treatments. And unfortunately, also, most of the prior trials have had a big group of patients that are very diverse and different. And not until all patients are randomized properly, then we're going to have an answer about what works for some and what doesn't.
Yeah, excellent. Tumor treating fields, I think, remains a pretty controversial topic in neuro-oncology, and some institutes really believe in it, some don't. You guys clearly use it. I mean, what are your decision points right now when you're deciding whether or not to use it for a patient? Are you using it up front on the majority now? Or are you really saving it for recurrence? Is it patient dependent? Does it depend on someone who's going to really use it?
Yeah, I'll speak for the neuro-oncologists. We always offer the device to most patients. Obviously, they're participating in a different trial, then they won't be offered the device. But in general, I understand it's quite controversial. I think I'm in favor of it. The trial was very strong, and the results are very convincing, although, there are many that argue against it. And it's not easy to use also. So we reported the percentage of usage, which is about 50 to 60%, and some patients get tired. But the new machine is very small. I remember when it started, patients had to travel with a big bag, and now it's just a very small portable bag that they can easily use. So we always offer them to patients, and then they get to decide if they want to use it or not in both newly diagnosed and recurrent setting.
Yeah,
and our center participated in the original trials.
I think it's very, very intriguing work that they're doing just as a company in and of itself. I think it's very fascinating whenever we don't fully understand how something works, but it seems to be working. And I think you guys contributed greatly to a better understanding of maybe when to use it. That said, I would probably still just use it no matter what, because you never know, right? That the NGS, it's 205 genes, but maybe there are some other ones that also work better, right?
Correct. Yes.
So you never know. Anyway, guys, we try to keep it short. Any final comments before we get you out of here?
No, I think thank you again for having us here.
Thanks for having us.
We'll keep supporting, and hopefully we can be back at some point.
I guarantee you will. So this will be up. It's on YouTube live right now, but it'll be posted on YouTube. You guys can share the clip with all your colleagues and friends and enemies and patients and whoever, and we'll have you back as soon as we can. All right.
Thank you.
Have a great afternoon, everyone. Thanks so much. Take care.
Okay, guys.
Bye-bye.